Okay, welcome sa part 2 ng ating video lecture about sa 3-moment equation. Okay, so we have here an example of a 2-span continuous beam under this kind of loading. Okay, so ito guys, basic pa lang naman to, no? So dito, kino-consider muna natin yung walang mga support displacements. Kasi kapag may support displacements na, definitely magkakaroon ng value itong H1 tsaka H2. Okay. So, what we're going to do here is to solve for the reactions at the supports. So, meron tayong tatlong support dito sa points A, B, and C. Okay. So, gagamitin natin dito syempre yung 3-moment equation. So, let me cite this again. So, we have MAL1 plus 2MB times the quantity L1 plus L2 plus MCL2 plus 6A1A1 over L1. Yan yung 3-moment factor sa left span. And 6A2B2 over L2. Yan naman yung 3-moment factor dun sa right span. And that is equal to what? 6AI times the quantity H1 over L1 plus H2 over L2. So sabi ko nga kanina, yung values ng H1 at H2 rito ay parehas na 0. So that's why nilagay ko na dito as 0. And we all know, dito sa points A and C, dahil simply supported yun, no? Or rather, hinge and roller yung support, okay? Meron ditong moment sa interior support na to. And mamaya malalaman natin kung ano yung magiging magnitude ng moment dito. Okay. So, as we all know, dahil nga hinge and roller to, yan yung isa ng ating moment diagram, no? Kung mag-drawing tayo ng moment diagram, definitely the moments at A and C are equal to 0 unless there is an applied moment there. Yun yung magiging value ng moments sa points A and C. That's why I indicated here MA and MC both equal to 0. So we also have what? L1 and L2 nagkataon na parehas 4 meters. So yung left span is 4 meters, then yung right span is 1 plus 1 plus 2, that is 4 meters also. Okay. So under this type of loading, meron tayong dinerive dun sa part 1. So you can check the previous video sa part 1 kung ano yung ating mga derived 3-moment factors. So for this kind of loading, okay, ganito po, no? So we have 2WL cube over 15 there. Okay? So, gagamitin natin yung recta, no? Para hindi na tayo gagawa nung moment diagram by parts. Kasi, definitely matagal talaga yon. Okay, so we have what? 2 times 1,400 times 4 cube over 15. Okay, it's better to write the 3-moment factors and even the other quantities here in terms of fraction. Mamaya natin malalaman yung significance kung bakit, no? So leave that for accuracy. Okay? And then, take note this is 35,840 over 3. And take note the unit, this is Newton meter squared. Okay? Tandaan nyo pong maigi yan, no? Kasi yung area, okay, is Newton meter squared. Okay? And then, times mo ng A1, na distance, so magiging Newton meter cube yung taas. I-divide mo ng length na L, that is meter, so magiging Newton meter squared. Okay. And how about this loading sa right span? So, ito, concentrated load lang naman to. So, we can use PB times L square minus B square over L. Ito yun, no? Para dito. But, for this one, since hindi naman yan kasama dun sa na-derive, pero kung matatandaan nyo dun sa last example natin, mag-solve tayo ng 3-moment factor. Okay? We are going to use integration. Gagamit tayo ng same process kagaya ng ginawa natin dito. And we just indicate that the value of P, okay, kung kukuha tayo ng strip dito, okay, this is dx, ang value nito ay mismong 800. So, we have here 800 dx. Okay? Ang distance niya from the left support, okay, yung left support ng span niya ay palaging x. Okay, ito po yun. So that, this one is what? Okay, this is 4. So this is 4 minus x. So yan yung tumata yung b natin. Kaya 4 minus x ito. Okay, so pb times l squared minus b squared over 4. Hindi ko na masyadong i-elaborate ito, no? Okay, you can refer to the previous video kung kailangan nyo ng konting enlightenment, no? So we get here, yung sum ng dalawang to, actually by superposition, i-add lang natin, we have 10,325 Newton meter squared. Okay? And then, i-substitute natin lahat ng kailangan natin dun sa 3-moment equation. Okay? So, MA is 0, so mawawala tong term na to. What else? Yung MC 0, mawawala din yung term na to. H1 and H2 are both 0, so magiging 0 yung term na to, tsaka to. So, yung entire term sa kanan magiging 0. Kasi 6EI times 0 will become 0. Okay. So, L1 and L2, as we all know, these are both 4 meters. So, substituting, we have 2 MB times the quantity 4 plus 4 plus 35,840 over 3 plus 10,325. Ito yun, equal to 0. So, what is MB? So, 4 plus 4 is 8 times 2, 16. So, kung ano man yung sum nito, di-divide natin ng 16. Then, by transposing it to the other side, magiging negative. Okay? So, definitely, kung walang applied moment dito, ang magnitude ng moment sa interior supports ay palaging negative. Tandaan nyo po yan. Palaging negative yan. Regardless, no? As long as walang applied moment dito sa span. Okay? So, roughly, that is negative 1,391.98 Newton meter. Okay? So, paano natin kukunin yung reaction? So, kung natatandaan ninyo dun sa ating previous part, okay, pinaghiwalay natin yung effect ng load tsaka ng end moments. So, at this case, kukunin natin yung reaction dun sa span due to the loads. Okay, so ang teknika natin dito, paano nga yan? Kukunin yung resultant. So 1,400 times 4 divided by 2, that is 2,800. Nandito yon newtons. And this is at distance 4 over 3 from the right support. So ang technique natin dito, guys, dito sa portion na to, divide mo kagad ng 3 ito. So we get 2,800 over 3. Then this quantity times 2 mo, matik ito yon. Okay, so 2,800 over 3 times 2 magiging 5,600 over 3. Okay, and in the same manner, kukunin din natin yung reaction dito, parang simple supported beam. We get here 1,075 newtons. Ito naman 1,425 newtons. Okay, we need also to get the reaction due to the end moments. But since sabi nga natin sa point A, guys, ito yung point A, no? Ito yung B rin ito, C ito. Walang moment dun sa points A and C. So, hayaan lang natin siya dito. So, for the left span, meron tayong unbalanced clockwise moment na equal saan? Negative 1,391.98. Nilagay ko lang siya as fraction. Okay. So, dahil clockwise yung moment dito, kailangan kontrahin ng reaction yung unbalanced moment na yun na clockwise. So, dapat itong dalawang to, counterclockwise, na couple. So, ibig sabihin, from the equation na moment equals force times distance, so, yung moment na ito, divide mo ng perpendicular distance between these two, 4 meters. So, makukuha natin to. 66,815 over 192. Nilagay ko siya as fraction. Okay, para mas accurate yung makukuha natin na sagot, no? So, kaya pababa to at pataas to, that is to ensure that the moment produced by this couple is counterclockwise para makontra nyo yung clockwise dito. Okay. Ito naman, in the same manner, parehas lang. So, dahil counterclockwise naman yung unbalanced moment dito, kailangan clockwise yung couple dito. So, clockwise naman to, pag ganon. Okay. Then, what else? Ano yung susunod na step? Yung reaction dito sa A is the sum of this 2,800 over 3 tsaka ito. But since pababa ito, so this one minus this one, you will get this one. Nilagay ko na yung decimal form niya, 585.34 newtons. Okay, so lahat naman ng nakatutok sa B, pag-add din natin. So we have what? 5,600 over 3, 1,075. This 66,815 over 192, and the other 66,815 over 192. So we're going to get 3,637.66 newtons. And then for C naman, we have 1,425 minus this one. Okay, we are getting 1,077.01 newtons. Okay, so upon checking, makikita natin na it will satisfy summation of forces vertical, also summation of moment. Okay, we are going to proceed sa next example. Okay, so we have here our second example. Ito naman, tatlong span yung beam natin. Okay, so we have 4 reactions or 4 supports na mag-i-induce ng reactions. We have RA, RB, RC, and RD. Dito sa gitna, mas malaki yung moment of inertia, so in-indicate natin siya as 2I. Okay, or which means that the moment of inertia sa middle span ay twice ng moment of inertia sa magkabilaang span. Okay, so since itong dalawang to ay hinge and roller, yung moment dito parehas na 0. That's why I indicate it as 0 here for both end moments, no? H1 and H2 for both cases parehas na 0. So meron tayong tatlong span. L1 is 4 meters, ito yon. L2 3 meters, ito naman yon, and L3 is 4 meters, ito naman po yon. But since the moment of inertia is not constant, kagaya ng ginawa natin dun sa area moment method, i-distribute natin yung effect ng moment of inertia sa kada span. Okay, so that meron tayong divisor na I1. Okay, para sa lahat na may involved na L1. So, L1 over I1. Kapag L2 naman, may involved na I2. May divisor na I2 dito, guys, no? So, it is self-explanatory. Lahat lang ng may subscript na 1, lalagyan mo ng I1. Lahat ng may subscript na 2, lalagyan mo ng I2 sa ilalim. Okay? So, dahil yung H1 at H2 parehas na 0, yung right hand term magiging 0. Okay. So, gagamitin natin yan para dito sa span na to. Yung span 1 and span 2, pagpaparisin muna natin. So, ganyan technique dito, guys, no? Pagparisin mo yung span 1 and span 2 so that meron kang moments A, B, and C for 3 moment equation to be used. And then we have span 2 and span 3. So we have B, C, D here. So ibig sabihin, dalawang beses tayong gagamit ng 3 moment equation. Una para sa span 1 and span 2. And then pangalawa para sa span 2 and span 3. Okay. So we're going to let I1 is equal to I. Siyempre, ito yan, no? I2 is equal to 2I and I3 is equal to I. So, ito naman yon. We need to compute the 3 moment factors for the left span dito. So, kung dito ka sa span na to, itong dalawang to, this is a left span and this is a right span. Pero pag ginamit mo itong dalawang to, ito ay magiging left span, ito ay magiging right span. So, ang ibig sabihin nun, kukunin mo yung 3 moment factor nito na nasa kaliwa siya, kukunin mo yung 3 moment factor nito na nasa kanan, and this one, you will get the 3 moment factor na nasa kaliwa at nasa kanan. Okay? So, paano po ito? Kagaya ng ginawa natin kanina, kukuha tayo ng strip, is dx, so ang height nito 400 kasi ano yan, uniform na distributed load. So, ang P natin dito is 400 dx. So, ito yon, 400 dx. So, gagamitin natin si P8 times L square over A square over L. Okay, ang limits natin from 0 to 3 only kasi doon lang nakakalat yung load. Okay, so we're getting 5,175 Newton square meter. Okay, for this one, kunin muna natin yung 3 moment factor bilang right span siya. Okay, so dahil right span yung gagamitin natin at nandito yung corner o yung vertex ng triangle, we need to use 2WL cube over 15 para yan dito. Okay, so 2 times 800 times 3 cube over 15, we get 2,880 Newton square meter. We need to also get the 3 moment factor of this span na nasa kaliwa siya para magamit natin dito sa span 2, span 3. Okay, so we need to get here 7WL cube over 16. Nasa part 1 po yung derivation natin dyan. Okay, so gamit naman to, makukuha natin yung 2,520 Newton square meters. And then for this one, sabi ko nga kanina, right span ito. Kahit saan mo tignan. So 600 times 3, okay, that is 1 plus 2 kasi nga right span siya. So PB times L square minus B square over 4. Ito naman, 700 times 2 times 4 square minus 2 square over 4. Okay, makukuha natin yung 7,350 Newton square meters. Okay, so take note of these 3 moment factors. We're going to substitute it accordingly. Okay, so gamitin muna natin tong unang 3 moment equation na to. Okay, so we have MA L1 over I1, but since MA is 0, mawawala to. Okay, yung MB tsaka MC, dahil nasa gitna yan or interior supports yan, definitely mayroong moment dyan. Okay, so we have 2MB, L1 is 4, so sinubstitute natin to dito. I1 is I, nakalagay yan dito. L2 is 3 meters, nilagay yan dito. I2 is 2I, nilagay din natin yan dyan. Plus MC times L2 na 3 meters divided by I2 na 2I, ito po yun. Plus, okay, this one, take note may I1 dito, no? But I1 is I, kaya ito ay 5,175 over I. Plus, 2,880, take note kasi right span, no? Over 2I, kasi yun yung moment of inertia dun sa span na yon. Okay, kung mapapansin ninyo, lahat ng terms dito, no? Pwede natin i-factor out yung 1 over I. May 1 over I dito, may 1 over I, may 1 over I. So, actually, pwede makancel yon. Okay, so pag multiply natin ng I, maka-cancel talaga yon. Okay, so we have what? 4 plus 3 halves, that is 5.5 times 2, magiging 11. 3 divided by 2, 1.5. And then, 5,175 plus 2,880 over 2, 1,440 ito. Makukuha natin yung 6,615. Paglipat sa kabila, no, magiging 6,000 or rather negative 6,615. And this will stand as our equation number 1. Kasi dalawa yung unknown natin. Kapag ginamit natin to in the same manner upon substitution, okay, self-explanatory naman yan. You can pause the video anytime if you want. We have 2,520, ito yon over 2i kasi yun yung moment of inertia sa span na yon, ito yon, plus 7,350 over i. So katulad kanina, common yung 1 over i, so we can multiply it by I kasi 0 naman to. Okay, 3 divided by 2, 1.5. 3 halves plus 4, 5.5 times 2 magiging 11. So yung sum nito magiging 8,610 paglipat sa kanan, negative 8,610. And this will become our equation number 2. Okay, so ito hindi na to theory of structures, no. We need to solve the values of MB and MC. This is two equations to unknowns. So we are going to get MB negative 504 Newton meter and MC negative 714 Newton meter. Okay, so paano naman yung reaction? Okay, gano'n lang ulit kasimple. Kukunin natin yung reaction as simple supported beam. Okay, this is your task already kung paano kunin to. Guys, kayang-kaya nyo na yan. Statics lang yan. Ito, mas madali ito, no? So, 800 times 3 2,400 divided by 2, 1,200. Anong sabi ko kanina? Divide mo ng 3, 400. Ito yon. Times mo ng 2, ito yon. Okay, and ito, summation of moment lang naman yan guys, no? So, this is 800 and 500. Okay. So, this is, kanina yung MB, negative 504 Newton meter. Negative, no? So, ganyan yung orientation niya, no? And dito naman, MC, negative 714 Newton meter. Okay? So, 504 divided by 4, 126. So, clockwise ito. Dapat ito, counterclockwise. Okay? Dito muna tayo. 714 divided by 4, 178.5. Since this is counterclockwise, dapat itong dalawang to, clockwise yung rotation. Balik tayo rito. Since mas malaki yung 714 sa 504, ibig sabihin, yung unbalanced moment dito, clockwise, okay, around 210 kN meter yon. Newton meter rather. So, yung clockwise na yon, kailangan makontra ng counterclockwise. So, 210 na clockwise, divide mo ng 3, okay, kaya naging 70 rito. Okay, and kagaya ng ginawa natin kanina, 750 minus 126, makukuha natin yung 624 newtons. 450 plus 800 plus 126 minus 70, makukuha natin yung 1,306 newtons. For this one, 400 plus 800 plus 70 plus 178.5, okay, makukuha natin yung 1,448.5 newtons. And 500 minus 178.5, makukuha natin yung 321.5 newtons. Okay, so baka may magtanong, bakit po ganyan yung orientation ng moment dito? Okay, tandaan, dahil nga negative ito, kukuha lang tayo ng maliit na portion dun sa support. So, dahil nga negative moment ito, halimbawa, ito yung support natin, no? Dahil negative moment to guys, may tendency, ang tendency niyan, yung bending niyan, pag ganito, nakasimangot. Okay, so para mag-bend yan ng ganyang paraan, okay, kailangan yung applied moment, ganito. Na-imagine nyo ba? Pag pinihit mo pa ganon, tutupiin ng pag ganyan. Okay, para sumimangot. Okay, so by principle of transmissibility, yung counterclockwise dito na moment, pagpasa mo rin sa kabilang span, magiging clockwise. Yun yung reason kung bakit ganyan yung ating direction. So, ito naman, dahil clockwise ito, by principle of transmissibility, clockwise yan, counterclockwise sa kabilang span. Okay, same thing goes here. Okay, so ganyan po yung technique kung paano malalaman yung rotation. Okay, so we have here our last example. Okay, so sa ating last example, meron tayong fixed end ngayon dito. So, under this type of loading, okay, kukunin natin yung mga reaction dun sa supports. Okay, kung mapapansin niyo, meron ding overhang dito. Okay, so regardless of the loading sa overhang, this is actually a determinate portion. When say determinate, makukuha natin yung moment dito sa point B. Okay, by observing what are the loads applied dun sa overhang. So, meron tayo ritong 6 times 1.5, that is 9 kN meter. So, definitely, meron tayong moment na 9 kN meter sa point B. Ang tanong, is it positive or negative? So, to answer that, it should be negative. Okay, kasi for sure, negative moment yun doon. Under the loading na binigay. Kasi pababa ito, no? So, kagaya ng moment diagram by parts, no? Pag nag-drawing tayo rito ng moment diagram by parts, due to 6 kN meter, so, dahil pababa yung loading dito, pababa din yung moment diagram. So, kaya, negative 9 kN meter. We need to observe the sign here na negative. Maliwanag po ba yun? Okay, so, ang technique dito, guys, is mag-drawing ka ng imaginary span dito. Okay, when say imaginary span, yung length niyan 0. And also yung moment dito, syempre 0 dahil nga imaginary lang naman 'yon, guys, no? So dahil wala rin naman load dito, dahil nga imaginary siya, so yung 3 moment factor dyan sa span na yan, automatically will be equal to 0. Okay, so ang gagamitin natin ng 3 moment equation is yung points B, C, and D. Kumbaga, ito yung ating span 1, ito yung ating span 2. So that we have what? MBL1 plus 2MC times the quantity L1 plus L2 plus MDL2 plus 6A1A1 over L1 plus 6A2B2 over L2 equal to 0. Since wala naman ding support settlements. So dahil nga sabi ko kanina, imaginary span lang to, so wala namang load talaga dyan. Dahil ito ay left span, ito naman ay right span. Take note guys, no, hindi mo i-consider to kasi determinate portion yan eh. Okay, so dito sa span na to, walang load dyan. So this will be automatically equal to 0. Nandito naman yan sa baba. No? Okay, so ang challenge dito is to get the 3 moment factor for the left span under this loading. Okay, so actually, no, may technique dito. You can use your calculator para makuha yung value ng y. But take note, the length of the left span is 3 plus 1 plus 1 na 5 meters. Okay, yun po yung importante rito. Again, by similar triangles, we have y over 3 minus x. Ito yun, is equal to what? 4 over 3. So that we get the value of y is equal to what? 4/3 times the quantity 3 minus x. Kung mapapansin niyo, yun yung differential force dP equal to y dx. At ito yon, ito yung y dx. Okay, yan yung y, no? So dahil left span tayo, yung value ng a natin ay yung x. Okay, ulit ha, yung length ng left span ay 5 meters at hindi po 3 meters lang, no? Okay, so we have the integral of y dx, in which y is equal to this one times a times L square minus A square over L. Okay, yung load ay from x equals 0 to 3. Tandaan nyo po yun guys, no? Para yan dito. And then, para naman dun sa applied moment, 4 meters from the left span, okay, from the left portion of the first span, and 1 meter from here, ibig sabihin yung A doon ay 3 plus 1 na 4 meters. Okay, so ginamit natin yung formula na dinerive natin sa part 1. So we have m over L or negative m over L times the quantity 3a square minus L square. Kung natatandaan ninyo, yan yung negative m over L times 3a square minus L square. So dyan po galing yan. Okay, so makukuha natin to as 26.76. Ito naman, negative 18.4. So therefore, by principle of superposition, makukuha natin yung 3 moment factor dito as 8.36. Okay? So, dahil alam natin yung value dun sa moment at B na negative 9 kN meter, ito yung isa-substitute natin dito sa MB rito. So, punta tayo rito. We have negative 9 times L1 na 5 meters. Yan yun, no? Yung length ng span na to. Plus 2MC times the quantity L1 plus L2. Yung L1 ay 5, yung L2 ay 0. Plus MDL2. Eh, parehas lang naman yan eh. Wala yung M dito. Wala rin yung length. So, kaya 0 yon. Plus 8.36 plus 0. Ito yon. So, we have 5 times 2, 10. Okay, magiging negative 45 plus 8.36. Negative 36.64 equal to 0. So, MC is positive 3.664 kN meter. Ano ibig sabihin nun? Clockwise yung rotation. Tama nga naman, no? Clockwise siya rito. Okay? And then, we need to get the reaction, no? So, since cantilever, lalabas na cantilever ito. Okay. So, yung 6 sasali lang nung fix dito. Pinaghiwalay lang natin yung moment. So, ito, 4 kilonewtons, 2 kilonewtons. So, 9 minus 3.664. Okay, kung ano man yung sagot doon, divide mo ng 5. But since mas malaki yung 9 kumpara dito, ang unbalanced moment ay counter clockwise. So that yung rotation nito ay clockwise. So we get 1.0672. Then 6 plus 4 is 10 plus this, 11.0672. Then 2 minus this one, we get 0.9328 kilonewtons. So, upon checking, parehas lang po yan, no? Summation of forces, vertical equal to 0, and summation of moments at any point equal to 0. So, guys, kailangan lang dito ng konting practice. Makakuha nyo rin yung principle ng 3-moment equation. So, sa part 3 ng ating video, lecture for 3-moment equation, doon guys, magsasolve tayo dun ng beam deflections. Okay? Pwede kayang gamitin yung 3-moment equation sa pagkuha ng deflection ng beam. Okay? Yun yung malalaman natin sa part 3 ng ating video lecture. So, stay tuned for more videos na i-upload natin. God bless to all of you.